Alright, so let's talk about part E of this question, find the model's inverse function, where this is the function that we begin with, and we want to find the inverse of it. Let me bring up the whiteboard. So, that's our function. Now we want to solve this for t, basically. So we'll subtract 357.87 from both sides, and then simply divide by negative 2.97. And that is it. So finding the inverse of linear functions is a fairly simple process. It just involves a couple of steps. And there we go. There's our inverse. Now I do have it written backwards in the sense that I normally would have the output variable on the left-hand side and the function on the right, but you can just reverse the order in which this is written, and you'll have your function. All right, let's move on to number 21. On weekdays, Jane commutes to and from work. Her distance d from home in miles is modeled by the following function, where t is time in hours after the start of her commute. And then we're given this function d of t, which clearly is a piecewise linear function. And we've got a bunch of questions about it. Now, it's not absolutely necessary that you graph this, but I think it's a good idea, at least, and it doesn't have to be the most beautiful graph in the world, but if we could have a graph that kind of captures the main qualities of this function, that should be useful. So I'm going to do that. And I note first that I've got a piece, the first piece goes from 0 to 1.6. So I'm going to mark 1.6 here. And it starts at, in fact, actually, let's look at this. For 41.25t, at time 0, it's at 0, right? So I can tell that I'm just mentally calculating what 0 times 41.25 is, and that's 0. So at time 0, I'm at home, so there's no distance from home. And then I'm traveling at a rate of 41.25 miles per hour. I guess I'm not, but Jane is. And then after 1.6, I'll be somewhere up here. And if you want to know exactly what the coordinates of that point are, it's easy enough to find. We just multiply 41. Well, better turn this on. 41.25 times 1.6. And so that's 66, and that's the coordinates of this point. So this is 1.6, 66. And we connect a line there. And now notice that that's also 66. That's not an accident. That's because we don't want to have a jump in the graph as far as your distance from home, because you're not instantaneously going to be 5 miles away from home when you were 0 miles away from home an instant earlier. So this is going to be a connected graph. Now from 1.6 to 10.1, I'm not moving. I'm staying 66 miles away from home. I keep saying I, but this is Jane. Jane is 66 miles away from home at work, right? And then after that time has elapsed and she heads home, then she's going to be following Rule 3. And that's valid until 12.1. And so this one is a bit less clear what my other point to graph would be. We're going to have to calculate it by, and here's one way to do that, is I can input this function and then evaluate it at 12.1. I know it has a slope of negative 33. Let's write all this down. clear everything. And I might be doing a little bit of overkill here, but that's okay. I'll have a good understanding of the function when I get to the questions, and then that'll make answering the questions that much easier. So I'm going to evaluate this at 12.1 because I want to know where it ends up. I made the assumption that 10.1 was also 66, but we can see. Let's just check just to be sure. Aha. Did I enter that correctly? Oh, look at that. I've screwed up. That's supposed to be 399.3. I got in a hurry. So forgive me for that. Let me go back and run that computation again. Okay, there we go. So the importance of that is that I actually want this third piece to start at that point. I don't want it to start up here, start down here. I want all three of these pieces to glue together perfectly, okay? And so where is it going after the input of 12.1? We will be at 0, so we'll be at home. So that's nice. So 12.1, I'll be right here. Fix my picture a little bit, and I took too much out. That's okay. Okay. Now my slopes for each one of these, my slope here is minus 33. My slope here is 0. My slope here is 41.25. That might be useful information. I don't know. We'll see. All right, let's go now to our questions. So how far is Jane from home after 6 hours? So after 6 hours, that's here. So after 6 hours, I'm just sitting at work, so the distance from home doesn't change. It's just 66. So I don't really have to compute anything there. I can just say, oh, well, it's just 66. How far is Jane from home after 11 hours? Well, after 11 hours, I'm in this domain, and so I need to use piece 3. Luckily, I have already entered that in the calculator, and so I can just do vars, yvars, function y1 of 11. And that gives me 36.3. Okay, moving on. When is Jane 15 miles from home? Now, this is a type 2 question because that's a distance. That is a distance. And so I'm going to go to my graph just to illustrate this. Let's say if that's 15, I'm going to have two answers. I'm going to have an answer when I leave and an answer when I come back. So I have to really do two different situations. I have to say, all right, when is 41.25t equal to 15? And then I also have to do when is negative 33t plus 399.3 equal to 15. And we need to solve each of these. Now you can do calc intersect for both of them. That's fine. This one's pretty easy just to do by hand because all I have to do is divide. So I'm trying to find the easy way out wherever I can. So that's after 0.3636 repeating hours. Okay. And then for the second one, now it's not hard to do this by hand, but you know, I do have this already set up in calc intersect here. So why don't we just do calc intersect? Whoops. if I could do the calculator correctly. I just want to go to y equals and enter 15 for 2. Go to my window, and let's do zoom fit. Hopefully we'll get a decent picture. Notice I didn't sweat the details too much on my domain, and I'm kind of paying for that now because my picture isn't the greatest. You see, my line is smashed up down here. So really, I should have reduced my window to like 0 to. I mean, we know it's over here actually, so we could have just done from 10 to 12, really. Let's do that. I'll do from 10 to 13, and then I'll do zoom fit. This will just give me a better picture to do my calc intersect. Enter, enter, enter. 11.64. And that'll round to be 11.65. Okay. So there is part C. So part C was a little more involved. We actually had 2 things to consider. What about D and E? What is the function's average rate of change in the interval 10.1 to 12.1? Well, you really don't have to compute anything. For 10.1 to 12.1 is piece 3. We have already talked about the slope being negative 33, and that is the average rate of change, so it's just negative 33. I don't have to compute that because that's a linear, that whole portion is linear, and linear functions have constant rate of change. And so if I found the rate of change anywhere, I know it everywhere for that piece. What is the physical significance of my answer? Well, that's my speed, right? And that's my speed coming home. So negative 33 or 33 miles per hour. Okay, so that's the end of question 21. Let's pause the video, and then in the next installment we will start with number 22.